In 1.3 for piecewise functions, we worked on, in our student companions, page 10 of the Try It 2A. I'm also going to do another problem from your 1.3 additional practice worksheet, just so we can kind of compare how these two things are different. So to start, our first function has 3 pieces. So I've written the numbers next to each line so that we can kind of look at how we find values for each of them. So if I look at the first section, I know that I have a linear equation. So what we talked about with the linear equation is that I can just use the values that are the endpoints of my domain. So it's telling me that it's this line 2x plus 5 between the x values -6 and -2 inclusive. So that means that when I plot both points, they're going to be regular points as opposed to like open points or holes. And so since it's a linear equation, I can just plug in the 2 endpoints and then connect them, and that will create the correct line. So if I plug in -6 into 2x plus 5, I get 2 times -6 is -12, plus 5 gives us -7. And then 2 times -2 is -4, plus 5 is +1. Again, because I have equal on both of my inequalities, those are both just regular dots. So we're going to plot -6, -7, and -2, +1, and connect those 2 points to create the segment from the first piece of our graph. So notice that this domain ended at -2. Our next domain starts at -2. So this line is one of the few places where I might have 2 points. So I know that my graph is going to be on the other side of that line from where our first piece was. So this is really breaking our grid up into 3 different pieces because we have 3 different functions. So what's different about this one is that we are graphing now parabola because we have an x squared. So what we have to think about is if I just use 2 endpoints, that makes a straight line. So I'm going to have to plug in at least one number in between. So since I'm going from -2 to +1, those are pretty close together. Let's kind of mark where +1 is so we can see. It's a good idea for us to just plug in 0. We might want to also plug in -1 if we wanted to get a little more shape, but plugging in just the point kind of in the middle is sufficient. So if I plug -2 into 2x squared minus 7, I get -2 squared is 4 times 2 is 8 minus 7 is 1. When you plug in 0, the whole first term is 0, so you just have -7. When you plug in 1, 1 squared is 1 times 2 is 2, minus 7 is -5. So when we plot these points, remember the fact that these have no equal sign, that means these are both holes. So I'm plotting those as open dots. Everything else, though, is within the domain. So 0 makes this statement true, right? 0 is less than 1, but greater than -2. So that's going to be a regular point. So we're going to have an open point at -2, 1. So since we already had a point there, I'm just going to draw a circle around it. So I know I'm connecting that with my blue points. Then I have 0, -7. And then finally an open dot at 0, -5. So these 3 points are my guide for the parabola 2x squared minus 7. Okay, so if I look at this, I know that the 2 makes this kind of a narrow parabola, and we can see that through our points. And so our final piece is another line. Again, we know that because x is just to the first power. And so -4 minus x, that means that we can just plug in 1 and 3 and then connect them like we did in piece 1. So -4 minus 1 gives us -5. And -4 minus 3 gives us -7. So we're going to plot these 2 points. Since these both have equal signs, they're regular points. I don't have to worry about them being holes. So I have one -5, which is, again, filling the hole from the first graph. And then I have 3 -7. And I'm just connecting those points to create this last piece of the function. So notice that with this piecewise function, our domains each had 2 values. Okay, so the left side didn't continue forever. The middle part never can because it's between two other pieces. And then the right side didn't continue forever. What we saw on the additional practice worksheet is now something with two pieces and sometimes three, where we only have one number in our domain. Okay, so what's different here is two things. We only have one dividing line because this only has two pieces. So I have two pieces that are going to switch at 2. Okay, so that means that I'm at least plugging 2 into both equations. I then have to figure out what other value I can plug into these equations. So what I have to look at is the inequality. Okay, so this inequality tells me that x is less than or equal to 2. Okay, so this is telling me two things. This is telling me that this is a filled in point. The other thing is that I need to pick a number to the left of 2. So when x is less than 2 like that, I'm looking at a number to the left. I could plug in 1, but 0 is always a good number to plug in. So this means we'll plug in 0 for this guy. Versus for the other portion, it says x is greater than 2. So again, that tells me that this is an open dot or a hole. And it tells me I need to plug in a number bigger than 2 or to the right of 2. So if I look to the right of 2, let's just plug in 3. We could do 4 or 5. So I would always pick 0 on the side where you can. And then for the other side, I would just pick the closest number. So we're going to be substituting in 2 and 0 into the first equation, -1/2 x minus 1. And again, this difference is that we had to figure out what this number was, right? So we're checking, is 0 less than or equal to 2? That's true. That's why we can use that here. So if I plug in 2, -1/2 of 2 is -1, minus 1 is -2. And then if I plug in 0, the whole first term turns into 0, minus 1 is -1. Okay, so remember, on this highlighter is the only place that I can have 2 points. Okay, so anywhere else, I shouldn't have like overlapping graphs. This should be a function. So 2, -2 is here, and then 0, -1 is here. The difference now is that this tells me that it's going off towards infinity. So instead of just connecting the points like I did if it said 0 is less than or equal to x is less than or equal to 2, I just picked that 0, right? And so I actually have to go out towards infinity. So I'm going to go towards -infinity here and draw an arrow at the end. So if I don't have two numbers in my domain, I keep going, draw an arrow. Okay, so the same thing's going to happen on the other side. It's just now that we're on the right, our arrow is going to point towards positive infinity. Okay. So again, we picked the number 3 because 3 is greater than 2. That makes that statement true. So if we substitute in 3 and 2, 3 times 2 is 6 minus 7 is -1. And then if I substitute in 3, 3 times 3 is 9, minus 7 is +2. So we have 2 points for this one. Remember, the only holes can ever be on those highlighter lines. And so 2, -1 is a hole. So notice that this one doesn't line up the way that the previous problem did. So that's okay to have gaps. It doesn't mean that you're wrong if you have a gap. Our last point is 3, 2. And then again, because I picked that 3 myself. I'm not just connecting the points. I'm continuing on forever towards the right.